Hi, Scott and Darryl from Banner Engineering. The goal in any photoelectric sensing application is to provide an output to an external controller. But even those output types can be a little confusing, and there's a lot of things to consider on that front. Darryl, can you walk through a little bit on the output styles that we can get from photoelectric sensors and where we might use those?
Be happy to. So when it comes to discrete outputs, you have two options, PNP sourcing or NPN syncing. I'll start off with PNP. So as its name implies, sourcing, you are sourcing a voltage. So in the image that we're looking at here, you'll notice that we have power to the sensor. Plus is on pin 1, ground is on pin 3. And if you follow the line here, pins 4 and 2 are your outputs. In this normally closed contact configuration, we are sending plus volts to the load. Now that load could be a PLC, it could be an HMI, it could be a relay, it could be a number of different items. But so on the other side of that load, it must go back to ground to complete the current path. And so which one would you use? How do you know when you use a PNP or an NPN? And that's going to be determined by the PLC. For example, if you're using a PLC, it will be determined by the card if it wants to see a sourcing or a syncing input. So NPN is doing the opposite of sourcing, it's syncing. So in this example, if you look at pin 3, we have DC ground. So if you follow the trace again to pin 2, where the load is, we're going to send a syncing input. On the other side of that load, it's plus volts, again, completing the current path to turn on the output. There's another option. We have several sensors that have relay outputs. When would you want to use that? In some cases, you want to switch AC power. And what's nice about a relay is you can switch AC or DC. So in this case, we could power this sensor up because it's universal power. It can be powered up via AC or DC. You can power the sensor up via DC power and switch AC power. That's a big advantage depending on what your output needs to power up.
So Darryl, NPN, PNP, those are solid state style outputs, correct?
Correct.
And our relay interface that you're showing right now, that's obviously a mechanical dry contact. Right. What's the disadvantage of having a relay output versus one of those solid state outputs on an NPN or PNP?
Well, you know, we talked earlier about response speed, and our sensors are extremely fast, down to 10 microseconds. You won't get that kind of response speed with a relay. They're a lot slower. They can switch a lot of current, a lot of amps, but the disadvantage is they're slower, typically around 20 milliseconds. So if you have a high-speed application, probably won't work for you.
How about longevity?
Yeah, that too, because it's mechanical. There's only so much on and off actuation that these contacts can take. Eventually they're going to wear out, but we do spec that in our data sheets.
Excellent. All right, well, we want to thank you for sitting through and watching our modules on photoelectric sensing, the basics as it relates to oppose mode, retroreflective mode, proximity mode, and the output styles that go along with it. For Darryl Harrell, I'm Scott Banke. Thanks a lot.